Welcome. As you could see from the thumbnail, today I would like to share a story about how I built a pill dispenser. The idea for this project came to me while I was cleaning the shelves next to my desk. On one of the shelves, there has been a bottle of vitamin settings there for a long time. Vitamins I was supposed to be taking every day for last 2 years. No, if you are wondering whether I have actually been taking them, the answer is no. They are out of my sight, so I always forget. So, by making this, I could keep them in view and within easy reach. First, I had to come up with some constraints. This was meant to be just a prototype, a fun weekend project. For now, I'm using 28BJ48 stepper motor, but for second version I bought different motor. Next on the list was choosing an MCU. Sure, I could use an ESP and make it smart, but do I need to? A pill dispenser with Wi-Fi? Seems like overkill. It would just waste power for no real benefit. So I choose the CH32V003. It's a kinda new famous MCU based on a RISC-V, and I have been waiting to try it for a while. There weren't many other requirements, I just wanted to use photodiode to sense when the pill was dispensed. As always, I use FreeCAD, but this time I decided to use assembly while modeling. Before, I just positioned all my parts based on spreadsheet values, but this time I wanted to do it better. After some research, I landed on using FreeCAD's built-in assembly. After a bit of practice, I got the hang of it, but it was very frustrating to use. Sometimes it just crashed and few times it crashed horribly, so badly that the project file got corrupted and I had to go back and use backups. There is high probability that I was using it wrong, but in the end I figured that I still like much more having all parts controlled by spreadsheets. And even when the project gets bigger and slower, I still like this way much more. I would like to try again assembly somewhere in the future, but for now this is more than perfect. Next, I had to print all parts, assemble them, and write some code so I could test the first prototype. Everything went smoothly until my biggest concern became a reality. When I placed more pills in the hopper, it got stuck. Additionally, the pill wheel only had one hole, and I realized that adding more holes would allow it to dispense pills much more quickly. One of the options that I had is to put small evaporating motor in the hopper that could prevent the pills clogging. The other mechanical solution was just to make the hopper better. So I have just tried to test the idea of having the hopper with much more steep edge, so I made this abomination. I sliced it with the lowest possible infill and walls and printed it. Unfortunately, this still had pills clogging up. Looking around, usually other working hoppers are much taller and also have much taller converging path, so I left the idea of using a real hopper. Other mechanical solution was just to make holes for the vitamins where they will be stacked on each other. This solution resulted to be much better than I expected, but I was still a little bit disappointed that it's not a real hopper. The next step was to ensure that only one vitamin could be dispensed at a time. A pill was considered dispensed when it fell and interrupted the beam of light hitting the photodiode. The one little problem was that for monitoring changes in the photodiode's readings, I needed to have much better code. The horrifying way I have been controlling the stepper motor did not allow me to detect the change on the photosensor, because one motor step was just looped with sleep. While using sleep, I was wasting a lot of time when the MCU could be doing something better. The correct solution would be just to use hardware timers. Very simplified. Hardware timer is a specialized part of the circuit that is inside our MCU, and its sole purpose is to count clock signals. When the current clock count reaches a certain value, it does something, such as triggering an interrupt that will run our predefined function. Because this was the first time using this MCU, I had zero experience how to make it work. Also, unfortunately, in the MCU examples, I could not find any code example for how to use the timer the way I wanted to. So after a lot of hours of trying different timer settings and reading the docs, it still didn't work. But one weird thing was that I could not make any timers work in this project, even when the same code worked in different example projects. Then I got the idea to look into config file, and there it was. For some reason there was a setting which disabled any use of interrupts. So, after changing that, timers were finally working. Well, next time I will make sure to first check the settings and only after that try something else. But in the end I was happy that it was finally working. Next fun stuff was to make touch sensor work. Again, I wanted to use interrupts because that was the correct way to do it. And in the process I made it kinda detect the touch, and when I said detect I mean to make it crash when I touch the touch sensor. So after debugging for a while I just found that I have misspelled the interrupt function, and after fixing it everything worked. I had also added two status LEDs. Green LED means dispensing, red means that the hopper has no more pills and it needs refill. Next I had to finalize the whole design. For example, add something that will keep the pills not falling down when dispensed, or a hole in the lid so I could easily fill it up. The last task on my list seemed like the easiest, but it turned out to be the hardest and most frustrating. I couldn't use my CNC, I didn't want to order a PCB, so I had to solder everything onto a universal prototype board. The first issue came when I copied the schematic from my breadboard. On schematic I connected a resistor to the wrong leg of the photodiode, which cost me nearly a whole day of debugging. I kept measuring voltages and swapping photodiodes until I finally rebuilt the circuits from scratch and found a mistake. Then I likely damaged the voltage regulator or created a solder bridge under it, and when I powered the board, MCU released a magic smoke and died. Not wanting to waste more time, I removed the small SOT223 and used a breadboard friendly power regulator instead. After fixing that, the touch sensor was giving false positives. The problem was probably power noise, since it worked fine when MCU was powered through the programmer. Adding a capacitor helped a bit, but it still wasn't reliable. The final fix was to remove the interrupt and only register a press if the sensor stayed active for over a half a second. That worked perfectly. This is how it looks inside. And here is some rare footage of it actually working all together. Well, in the end I am happy how it turned out, but I am still planning on making version 2. Thanks a lot for watching and see you next time.